Okay, guys, today we're going to do Forces Vocab Part 2. You do not need to write this anywhere in your flip book. I was just giving you somewhere to start today. I found this cool little pointer thing. If I could, there we go. If I can get to it. And I'll use this as we go through just to help some of you guys. Okay, very first word that we're going to do today is inertia. Inertia, which is the act of an object resisting a change in its motion. Resisting means that you do not want to do it. So some examples are a ball rolling down a hill will continue to roll unless friction or another force stops it. So friction being maybe grass or gravel or concrete, all of those are different. So a ball would most likely keep rolling more if it was on concrete than in the grass. Or if it's on rocks, if it hits a big rock, it's probably going to stop it. So that's for that one. Other example, one's body movement to the side when a car makes a sharp turn. Think about how difficult it is to keep your body upright in a car. Whenever your car makes a really sharp turn, your parents forget where they're going and they turn this way really, really fast. Okay, it's really hard to keep your body up. So your body is going through inertia, the act of resisting a change in motion. Picture, got this lady trying to push a big rock. Okay, this rock is resisting its change in motion. No matter how hard she pushes, it's going to resist it. If it was a little bit smaller rock, it might resist for a little while and then eventually she'll be able to push it. But that resist is inertia. Okay, Newton's first law of motion. We are going to talk about 3 of these. I'm going to go over the first one right now, okay? We are going to have to memorize each of these, so I want you guys to try to pay attention, and we'll do some more activities on this. Now, Newton's first law is the motion of an object does not change if the net force on an object is 0. We've been talking about net force for about 2 days now, okay? So let's go ahead and look at this picture. We have 2 elephants, one on this side. He is pulling with a net force of 200. See that right there? And this elephant on the other side, he's pulling the opposite direction with a net force of 200. Now, if they both are pulling with the exact same amount of net force, those cancel each other out, and we get 0. Bringing us back to Newton's first law of motion. The motion of an object does not change if the net force is 0. So neither of these elephants are going to move. They're not going to break this log in the middle. They're just going to keep staying there and pulling at the same force and stay in the exact same spot. Try your best to draw these figures. Don't make them perfect elephants or you're going to just waste a bunch of time. So just try your best. Maybe draw stick people and label them with this amount, but keep this here. Okay, Newton's second law of motion. This one's a little tricky. I just want you to write down the definition and draw yourself a picture today, and we will do a lot of this later. Newton's second law is acceleration, which is related to speed and force, is equal to the net force exerted on the object divided by the object's mass. So this is basically a math equation that we're going to use in here to discover acceleration. Acceleration is equal to force divided by mass. And we could switch that around a couple of ways to figure that out. Maybe we just wanted to figure out the mass or just wanted to figure out the amount of force. We'll practice all of that later, so just get it written down for now. One picture, acceleration is the change in velocity. Velocity could mean speed, direction, and both. So acceleration is related to all of these, okay? Here's your formula again. It's changed up a little bit from this one over here because you guys know with formulas you can change them around depending on what variable you want to find. If you're trying to find the force of an object, you're going to do mass times acceleration. So the more force that you move something, the more force you use, the more acceleration or the more speed or farther it's going to go or stuff like that, okay? And lastly, we have Newton's third law of motion. So there's only 3 of them. So we've done the first one back here. First law of motion. Then we did second law. Then we have third law. Newton's third law is for every action, there is an equal and opposite reaction. This is probably the easiest one that we are going to go over and probably the easiest one to remember. I think it's kind of catchy. For every action, there is an equal and opposite reaction. So those are 2 actions there, an equal action and an opposite reaction. Examples. Try to think about this as I'm reading through it, okay? Imagine yourself in the situation. As you sit in your chair, your body acts on the chair with one force, and the chair reacts on your body with yet another force. Okay. Your body acting on the chair with one force, that one force is gravity, because that's the weight of your body, okay, acting on that chair. And the chair, it's specifically built to hold that weight, so it's specifically built to push up on your body and hold it there. So that's the second force. So there's 2 forces acting. One, your force pushing down on the chair, the other one, chair pushing up on you, essentially to suspend you in the air and make you be able to sit in that chair. Okay, so if you think about equal and opposite reactions, okay? For every action, there's an equal and opposite reaction. Think about this tennis ball, okay? I'm holding it about 3 feet up in the air. I drop it. There's our first action. It goes straight to the ground. What is the opposite reaction that's going to occur? It's going to bounce right back up, right? So that's our reaction. Our action is dropping it. That's gravity, right? Pulling it down to the ground, okay? And then our reaction is as soon as it hits the ground, is it bouncing back up, okay? For every action, there's an equal and opposite reaction. We did this exact same thing with our very first lab the other day, last week, dropping the golf ball. You dropped the golf ball, that was your action. The reaction was it bouncing back up in the air. Okay, here we go with another one. We have somebody canoeing on a river, it looks like, okay? What is the action that she's going to perform first? She's going to paddle with this oar, okay? So as soon as she sticks that oar in the water and paddles, what is the reaction? The boat's going to move forward in the water. Equal and opposite reactions. One paddle going this way is going to force this boat to go that way. Okay, same thing with a balloon. We did this with experiment number 8 last week. We filled our balloon up with air, okay? Air is pushed out of the balloon in the back, right? That is our first action. Air has to come out of that balloon. And what is the reaction? The balloon's pushed forward. We did that on a string. You guys taped it to the straw and the string. We did in experiment 8. First action, air pushing out. Second action, balloon is moved forward. For every action, there is an equal and opposite reaction. I think that's the last picture. Yep.